Hi, welcome back. So today we're going to work on solving some algebraic equations that involve fractions. You're already pretty good at adding and subtracting, multiplying and dividing them, and you know that within geometric applications, you are measuring a lot of things and we still do it in feet and inches and end up with a lot of fractions. So it's important for us to be able to deal with fractions within equations because they're going to pop up inside of our geometric formulas. All right, so get your guided notes and let's give this a start. Algebraic equations involving fractions are not really any different than other algebraic equations we've had. For any algebraic equation, we will use these ideas of inverse operations to isolate the variable. Inverse operations are things that undo what some other operation did. So if you wanted to undo addition, you would use subtraction. Addition and subtraction are inverse operations. Along that same line, division and multiplication are inverse operations. To undo division, you use multiplication. To undo multiplication, you use division. As we start today, what we're going to do is compare what happens when we have integers inside of an algebraic equation with what happens when we have fractions inside of an algebraic equation. And the goal here is to show you that really there's not any huge hairy difference. So don't let a fraction inside of an equation intimidate you into thinking that we don't know what to do. It's the same stuff we've had before, with maybe one teeny tiny minor change. So let's take a peek at how this works. Okay, here on the left, we have an ordinary type of equation, the kind we used a long time ago. We have x subtract 34 equals 27. And to undo this subtraction, you know that we would add 34. And of course, we would do that to both sides of the equation. Equals has to stay right where it is. Drop it straight down. Equals never gets to move. 27 plus 34, well, that's just 61. And the whole reason why we added 34 to both sides was so that we would have some opposite terms here. Negative 34 and positive 34 are opposites, and that leaves us with just x on the left-hand side. And so x is 61. Nothing changes when we come over here and are dealing with the fractions. If we have x subtract 6/7, then to undo this subtraction, we need to add 6/7. And we need to do that to both sides of the equation. Just like before, drop that equals straight down. It never gets to move. We want to see the opposite terms here. Negative 6/7 and positive 6/7 make a great big fat 0. And on the right-hand side, we have 3/7 plus 6/7, which you know is 9/7. And of course, you'd never leave it like that. We would call it 1 and 2/7. Just like before, we can check this. We take our answer and drop it straight into the equation we started with. So we would have 61 plus 34, or sorry, minus 34, and make sure that that equals 27, which it does, and it checks. We can do the same thing for the fraction, drop it in for the x, but let's do it in its improper form. It's just a little easier to work with that way. So we have 9/7 minus 6/7, and that equals 3/7, which we know, and that one checks also. Okay, so not all equations are that simple, but the ideas are the same. If we're going to undo subtraction, we'll use addition. If we're going to undo addition, we'll use subtraction. The only thing that changes, so let's slide down to the bottom of the page here. There is one tiny difference, and it's really just a difference that makes things easier to work with. You already know that dividing is exactly the same as multiplying by a reciprocal. So with fractions, like we saw in the last lesson, it's sometimes handier to multiply by a reciprocal rather than to divide by a fraction. All right, so here we go. If you want to divide both sides of an equation by an amount, what we're going to do is multiply both sides of the equation by the reciprocal instead. All right, so over here we have what we might call the ordinary equation. We have 3 times x is equal to 17.1. And your first inclination, hopefully, is to divide both sides of the equation by 3. And we do that because 3 over 3 is worth 1. And that leaves us with x all by itself on the left-hand side. On the right-hand side, we have the division. 17.1 divided by 3 is equal to 5.7. And we're done. For this other equation, it's pretty much the same, except the right-hand side turned into a fraction. If we were going to divide both sides of the equation here by 3, then we would have a fraction inside of a fraction. Right? I'd have 2 fraction bars. If my handwriting is sloppy, or if I step away from my problem for a moment, or take a drink of coffee, something like that, and I look back at my paper, I might not be able to tell which fraction bar is the main fraction bar and get a little lost in what I was doing. It's just awkward to have a fraction within a fraction. So instead of dividing both sides by 3, what we'll do is multiply both sides by the reciprocal of this coefficient. So think of this 3x as 3 over 1 times x. And of course, the reciprocal of 3 over 1 is 1/3. So we'll multiply both sides of the equation by 1/3. And you can see that's how this 3 gets into the denominator. It's the same 3 in the denominator that was over here. Multiplying by 1/3 is the same as dividing by 3. But a nice thing happens here because 3 over 3 is 1. Of course, 1 over 1 is 1. And now we have just a plain old ordinary 1x on the left-hand side. The right-hand side now is perfectly clear. There's no question about where the numerators are, where the denominators are, or what needs to happen. When we look at this, there aren't any common factors, so we can just multiply straight across. And we end up with 4/33. You check this just like you ordinarily would. Right? 3 times 5.7. Make sure that that equals 17.1, which it does. Yay. Or we do it over here and we say, hey, I need 3 times 4/33. Again, think of that 3 as 3 times 1 so you can clearly see your numerators and denominators. This one is small enough. We can do it without a calculator. Right? We know 3 goes into 33 11 times. So divide out that common factor of 3. And then multiply straight across. And there we are, 4/11. Everything checks. All right, see, it's not that bad. That idea of multiplying by the reciprocal really makes things a lot nicer. Let's flip down to the next page. Okay, so here we go. 2/3 of some number is equal to 6/13. We need to figure out the number. X is, sorry, I guess that's 2/5, isn't it? Sorry, I couldn't read for a second there. 2/5 of some number is equal to 6/13. X is being multiplied by 2/5. Rather than divide both sides by 2/5, let's go ahead and multiply both sides by the reciprocal of 2/5. And you know that the reciprocal of 2/5 is 5 halves. So I've got 5 halves multiplied by 2/5 of an x is equal to 5 halves multiplied by 6/13. And you see how nicely this works out. 5 over 5 is 1, 2 over 2 is 1. I have 1x left all by itself. On the right-hand side, we look for some common factors. 2 goes into 2 one time, 2 goes into 6 3 times, and so we are left with 5 times 3, which is 15 in the numerator, and 1 times 13, which is 13 in the denominator. And of course, we'd rewrite this as 1 and 2/13. Let's not forget about the directions here, right? We need to check. Is it true that 2/5 multiplied by, use the improper version, 15/13 is equal to 6/13. Well, let's see. We're looking for common factors. 5 goes into 5 one time, 5 goes into 15 3 times. Sure enough, we multiply straight across. 2 times 3 is 6, and 1 times 13 is 13. And it works. That's great. And of course, you could use your calculator for all of this, but these numbers are kind of small. We should make sure we keep our mental skills sharp also. Okay, let's try something that's got a few more steps to it. What we really want to do is tackle this equation over here, which I know it looks kind of bad because there's all these fractions in there, but we are going to take a deep breath and not be intimidated by them, because it's exactly the same process as if we had something like this over here. So let's think about it. What would be the first thing that you would do if you were trying to solve 3x minus 7 equals 8x plus 3? We have a lot of options, but maybe you might decide to add 7 to both sides of the equation. Right? We see those opposite terms right there. And that leaves us with 3x on the left-hand side. Equals drops straight down and doesn't move. And then we have 8x plus 10. So let's come over to the other equation and do a similar type of thing. Let's add 1/2, to both sides. Remember to keep your like terms together. These are the constants. So we'll add constants to constants. Drop that equals straight down. See those opposite terms there. So we've got that big fat 0. And let's see what we have. 1/4 of an x is equal to 2/5 of an x plus, well, now we have 1/3 plus 1/2. Really, we should probably be able to do this one in our heads by now. The common denominator would be 6. 1/3 is worth 2/6. 1/2 is worth 3/6. We add them together, and that should give us 5/6. If you need to write it out, that's fine, but still, work on keeping those fraction skills sharp. If you think it's something that you could do by hand, if you tried a little bit, well, then try a little bit and make sure that we stay fresh with these things. Okay, so here we are. We have, step 1 is done on both equations. If we're not quite sure what's going to happen over here with the equation that involves fractions, let's come back to the other one and say what would be the next step. Remember that our goal is to get all of the x's on one side and all of the constants on the other, so it's this 8x that needs to go. And of course, to undo the 8x from the right-hand side, we would subtract it. And we'll subtract it, of course, from both sides of the equation. Okay. Guess I shouldn't have done that in red, but oh well, there it is. We see those opposite terms again. The right-hand side just has 10. The real question is, what just happened on the left-hand side? And you're looking at this and you're saying, well, clearly this is negative 5x. But we may have gotten so good at this that we've forgotten how we get these things. Where did the negative 5 come from? It's because we took the coefficient here, the 3 and the negative 8, and put them together. We combined those coefficients. All right, so let's come over to the other side and do the same thing. The job is to subtract 2/5 of an x from both sides. So we're not just subtracting 2/5, right? We want to keep those like terms lined up. Equals drops straight down. We see those opposite terms. On the right-hand side, we have 5/6 remaining. And on the left-hand side, we have some x's. We have 1/4 of an x, subtract 2/5 of an x, and the number of x's remaining is what we get when we take 1/4 and subtract 2/5. Just like over here, we had 3x and we subtracted the 8x by looking at those coefficients. So we just want to focus here. What is 1/4 minus 2/5? I tell you what, why don't you take a second, Practice that off to the side. Get some common denominators. Think about what you want that coefficient to be. Maybe check it on your calculator, and then come back. All right, 1/4 minus 2/5 should be a negative 3/20. Hopefully we got there. Okay, so our last step, I will come back over here. If I wanted to isolate x, I would need to divide both sides by the coefficient. Right? Divide the left-hand side by -5, divide the right-hand side by -5. Equals drops straight down. 10 divided by -5 is -2. On the right-hand side, we have -5 divided by -5, and that's just 1, and that gives us a plain old ordinary x. So here x is equal to -2. This is where things change. In the equation involving the fractions, remember our job is going to be to take this coefficient here, look at it, and multiply both sides by the reciprocal. The reciprocal of -3/20 is -20/3. It's really important to use your parentheses here so that it doesn't look like we are subtracting things. So we multiply both sides by -20/3. Let's see what that gives us. The left-hand side is pretty nice. A negative times a negative is a positive. 3/3 is 1. 20/20 is 1. And we end up with a plain old ordinary x. On the right-hand side, we have a negative times a positive. So that's going to give us a negative answer. And then we'll just look at the coefficients, the numerators and denominators to see if we have any common factors. Gosh, my brain stopped there for a second. I think I see only a common factor of 2. 2 goes into 6 3 times. 2 goes into 20 10 times. So now multiplying straight across, we have -50. And 3 times 3 is 9. -50/9. Let's see, 9 goes into 55 times because 5 times 9 is 45 with 5 left over. So we're looking at 5 and 5/9, but don't forget that this is supposed to be negative. Wow, that was a lot of work. We really ought to check this one. I think I lost my original equation. Hang on a second. All right, so let's see. The original equation was 1/4 of an x. Let's use the improper fraction because it's a little nicer when we're working by hand. 1/4 of an x minus 1/2. And that was the left-hand side. Remember, when we're checking, we're trying to make sure that the left-hand side and the right-hand side are equal. What do we have? You know what? Take a second again, pause, see if you can do this, try it on your calculator, and then come back. Okay, I came up with -17/9. Just for grins and giggles, let's make sure we can do this on the calculator. So we have a fraction, right? Numerator and denominator. This is 1/4. Multiplied by, use those parentheses keys, negative fraction. This is 50/9. Whoops. Go back one and delete that. Make sure we get the parentheses in the right spots. Minus, get a new fraction template. Ah, I did the wrong one, didn't I? There we go. Get a new fraction template, minus 1/2. And we'll come out of that fraction and see what we get. Oh, good, -17/9. Well, that's really reassuring. The right-hand side of the equation said 2/5 of an x, which was -50/9, plus 1/3. let's just speed this along. 2/5 multiplied by negative 50 over 9. Come out of the fraction, close the parentheses, plus 1/3. Whoops. Make sure the 3 gets in the denominator. All right, come out of that fraction and let's see what we have. Hot dog. So that is equal to negative 17 over 9. We have a nice match. So this checks. Okay, and I'll let you check the answer to the one on the right-hand side, but trust me, I made the problem. The answer is supposed to be x is equal to -2. Okay, but that's pretty much it. There's not a whole lot else to talk about in terms of algebra with fractions. If we flip the page, we'll see one more example, and that will involve these parentheses here and the distributive property, but that's really about as far as we can go. The only thing we want to talk about is what to do if you're in a situation when you do not have a calculator with one of these lovely fraction templates. And it's kind of cool that our calculator has it, but we don't always, not all calculators do. I know, you'd think they would, right? But they don't. We have to be careful dividing fractions on a calculator if we're just using the division key. So to show you what I mean, let's start off by working this particular problem by hand. We know that 2/3 divided by 5/7 is exactly the same as 2/3 multiplied by the reciprocal of 5/7, which is 7/5. We don't have any factors in common. Nothing's going to cancel here. We can multiply this straight across, and we know the answer is supposed to be 14/15. All right, so let's see what would happen if we did this on a calculator. 2/3 is 2 divided by 3. Divided by, so that's the middle division, 5 divided by 7, because 5 divided by 7 is 5/7. And let's see what happens. 2 divided by 3 divided by 5 divided by 7. Oh yeah, there's that decimal. Let's change that with our little converter thing. Most calculators have one of those. And look, that's 2 1/105ths. That's clearly not the right answer. So the real question is what just went wrong? And you could hear it when I was typing it in. I said 2 divided by 3 divided by 5 and divided by 7. What happened was that 2 got divided by all of these things because your calculator's following the order of operations. What we really want is to say, I want this whole number right here. This complete 2/3 is one entity. I want to take this value and divide by this other value, which is 5/7. In order for your calculator to do what needs to be done, we have to say first fraction in parentheses divided by the second fraction in parentheses. So let's try that again. 2 divided by 3 divided by, and the second fraction is 5 divided by 7. So now it looks like one fraction divided by another. So even if your calculator didn't have a fraction template, it probably has a way to turn fractions and decimals, convert between fractions and decimals, and there we would have this lovely 14/15 that we really want. All right, so the main point here is if you don't have a calculator that can work with fractions directly, then we want to hold each of these fractions in parentheses. Otherwise, you're going to end up with some answers that are way off, right? 2 1/105ths was nowhere close to what we wanted. Okay, well, aside from that, this is our last example. And let's see what we can do. I'm going to start you off on this one, and then I'm going to let you finish it. On the left-hand side, you should be seeing a distributive property. Really, there should be this nice little tingle traveling down your arm, you know, that feeling that says, I must distribute. You know, don't hold back. Go ahead and do it. We need 1/5 multiplied by 1/2. That's a really easy multiplication. We know that that's 1/10. Don't forget the x. And then we need 1/5 multiplied by 5. and that is just 1. So now we have 4/5 of an x plus 15. All right, so what I want to have happen here is that your work looks like mine. Not that there's only one way to do this, it's just that when you come back, I want you to be able to compare what you did with what I did. So here's what I'm going to ask you to do. Start by moving the x's to the left. Subtract this 4/5 of an x from each side, and then move the constants to the right. Pause the recording, give it a shot, and then come back when you're ready. Okay, let's see how things are comparing here. To move the 4/5 of an x over to the left-hand side, we have to subtract it. From both sides. Remember, the equals stays right there in the middle. It never gets to move. We see those nice opposite terms that make a big fat 0. The right-hand side has only 15 left. On the left-hand side, well, there's a plus 1, and I have 1/10 minus 4/5. Our common denominator is tenths, so really we're looking at 1/10 minus 8/10, which is -7/10 of an x. Hopefully you did that without your calculator. Okay, now we need to get the constants on the right-hand side, so we'll subtract 1 and subtract 1 again. Equals stays right where it is. 15 minus 1 is 14, and the left-hand side is -7/10 of an x. Okay. We have this feeling we might want to divide both sides by -7/10, but we know that that's going to look really awkward. So rather than divide both sides by -7/10, we'll multiply both sides by the reciprocal. So -10/7 gets multiplied by -7/10. We know that that's the right thing to do now because we can see the things that are going to cancel. Those nice common factors are all over the place. And we'll do the same thing on the right-hand side. Might not be a bad idea to make that 14 into a fraction. All right, so -10/10 is 1, 7/7 is 1. We're left with a great big fat 1x on the left-hand side. On the right-hand side, we look around for some common factors. 7 goes into 7 one time, 7 goes into 14 twice. -10 times 2 is -20. Oh, that feels kind of nice, doesn't it? It's kind of good to get a number that's not a fraction for an answer sometimes. But we should really be nice and complete about this whole thing and check. So here we go. On the left-hand side, we have 1/5 of 1/2. That's multiplied by -20 plus 5. Let's just see what the calculator has to say about that. So we'll grab our fraction template. We have 1/5 multiplied by 1/2. And that half is being multiplied by -20. It is okay to have parentheses inside of parentheses, just like it's okay to have them on your paper this way. Just make sure that they all have an open parentheses and a closed parentheses. So it should look exactly like you have it on your paper. And let's see what that is. Oh, -1. Okay. Not a bad answer, except that we don't know what the right-hand side's worth, and these both have to match. So we'll try the right-hand side. We have 4/5 multiplied by -20 plus 15. And maybe you're able to do this in your head. 5 goes into 20 4 times. 4 times -4 is -16, plus 15 gives us -1. If not, we'll go ahead and use the calculator. That's okay too. 4/5 multiplied by -20. Just don't forget those parentheses. Plus 15. There we go. So that's equal to -1. And both sides match. which is what we wanted. So our answer checks. Okay, so that's about it. Get started on your homework, and we'll see you during the next lesson. Have a great day. Bye-bye.